We need to reinforce the fuselage so that it will withstand the 40 psi we will put on it so it will launch. If it is not reinforced, it will explode from the massive force within the bottle. It is then put into the tip of the nose cone so that it adds more mass and more inertia. So once the fuselage reaches its peak, the nose cone will detach and it will deploy the parachute. Fill the rocket halfway with water so that when we put enough air into the bottle, it will create so much air pressure that when we release the bottle, it will shoot the water out, causing an action force, and the bottle will be launched, causing a reaction force. It will make a parachute so that it'll slow the rocket's descent and won't hit anyone on the way down. When we added the extra mass to the nose cone, it was so that way when we launch the rocket, the nose cone will fall off, deploying the parachute. The altimeter works by measuring the angle and degrees in which an object you are pointing at, and then use a specific formula to turn it into an altitude measurement. And distance and time give us speed, because speed is a certain amount of distance traveled in the amount of time, in a set amount of time. So in this case, the slope of this graph of distance and speed is 2, meaning the speed of the object we're graphing is 2 miles per hour. We take ground-to-ground measurements to see how long it takes for the bottle to go from the ground to the ground, from when it launches and then when it comes back down to the ground. In this case, Jason's rocket took 1 minute and 60 seconds to leave the ground and then come back.